Hello, students, future architects, future engineers, subscribers, and viewers. Here is a video on solving or resolving a force into its components, but this time with respect to U and V axis, not necessarily perpendicular to each other and not necessarily parallel to the X and Y axis. So I hope that you will enjoy watching and you will learn from this video. In the second part, I will discuss and explain how to obtain the resultant of coplanar concurrent force systems. So let me proceed directly so that the video will be short. Resolve the 180 Newton force into U and V components. So this is the U axis and this is the V axis. Notice that the U axis is rotated from the X axis through an angle of 15 degrees. The V axis is also rotated from the Y axis through an angle of 15 degrees. Therefore, the angle between U and V is 90 degrees. So in other words, that's 90 degrees. Because the angle that the U axis makes with the Y axis is 90 degrees. So this angle here is 90 degrees minus 15. So 75. So 75 from the U axis to the Y axis, 75 degrees plus 15 degrees is 90. So they are perpendicular to each other. So by principle, to obtain the components of the 180 Newton force along the U and the V axis, we draw lines from the tips of the force, and those lines should be parallel to the U and V axis as shown. And the measure of this angle is 35 degrees because the 180 Newton force makes an angle of 35 degrees with the x-axis, positive x-axis. So 35 degrees minus 15 degrees is 20 degrees. So this is FU and that is FD. Then from the tips of the 180 Newton force, we simply draw parallel sides or the free vectors of FU and FD. So this supposedly parallelogram is reduced to a right triangle because, as mentioned earlier, the angle between the U and the V axis is 90 degrees. So this is the U axis and this component is parallel to the V axis. In fact, this is the free vector of the V component of the force. So that's 90 degrees. And we only consider this right triangle and this angle is 20 degrees. So FU adjacent to 20 degrees is hypotenuse, and the hypotenuse has a magnitude of 180 newtons when cosine of 20 degrees. So consider this right triangle. For those who cannot see it well, then you separate another right triangle so that you can analyze it well. So this is FU, adjacent side, then the hypotenuse is 180, so cosine of 20 degrees is FU over 180. So that's for the next problem. So this is the figure, but let's proceed to this. FU is 180 cosine of 20 degrees. 180 hypotenuse cosine of 20 degrees. FU is adjacent to 20 degrees. So solving for FU using your calculator, 169.1 newtons. Likewise, FV is opposite to 20 degrees. Therefore, FV is hypotenuse 180 times sine of 20 degrees. So 180 times sine of 20 degrees is equal to 61.56 newtons. So these are the components of the 180 Newton force along U and V axis. So this example, it happens that the U and V axis are perpendicular to each other. Definitely, in this problem, U and V are no longer perpendicular to each other, and we use the first axiom of mechanics, the parallelogram law, or we can reduce the parallelogram to a triangle. And remember the properties of parallelogram: opposite angles are equal, adjacent angles are supplementary, or the sum of adjacent angles is 180 degrees. So that is presented also in my video, in the preceding videos. So by principle, we draw sides parallel to the U and the V axis through the tips of the force. By the way, if the components are given, it is like finding the resultant force. The diagonal, the main diagonal of the parallelogram is the resultant force. Given the resultant force, to find the components, it's like finding the sides of the parallelogram, or we can reduce that to a triangle. So this is Fu, Fv, then from the tips of that 240 Newton force resultant, we draw lines parallel to the U and the V axis to form that parallelogram. We will not deal with the parallelogram, we just use the properties of parallelogram. This is equal to Fv, the magnitude of this is equal to Fv. Let's consider this triangle, and 25 plus 45 is 25 plus 40 is 65 degrees. So that is also 65 degrees. This is 40 degrees equal to this, and this is 25 degrees equal to that. Then, since adjacent angle 65 and this angle must be supplementary, so the measure of this angle is 180 degrees minus 65 degrees. The other way of computing this, 180 minus 65 degrees, which is 115 degrees, is the fact that because this is 65 degrees, this is also 65 degrees. So take note, we have parallel side. This is the extension of the U-axis. So the angle between the U-axis and the V-axis is 25 plus 40, 65 degrees. So therefore, the measure of this angle is 180 degrees minus 65. So that's why this is 115 degrees. And 115 degrees plus 65 equals 180. So again, that's 65 degrees. So that's why this is also 65 and this is 115 degrees. 180 minus 65 degrees is 115 degrees. The other way is the fact that this angle, 65 degrees plus this angle, should be supplementary, or the sum is 180 degrees. So it's really 180 degrees. Finally, the measure of this angle is equal to 25 degrees. And to check, 25 degrees plus 40 degrees is 65 degrees plus 115 degrees is 180 degrees, which is the sum of the interior angles of a triangle. Since the magnitude of this side of the triangle is 240, we apply sine law to solve for the other components or sides. So that is Fb, that's 240. So by sine law, Fu as to sine of the angle opposite it, sine of 25 degrees equals Fv as to sine of angle opposite it, so sine of 40 degrees, equals 240 newtons as to sine opposite to that, which is sine of 115 degrees. So again, Fu as to sine 25 degrees by sine law equals Fv as to sine of 40 degrees, then equals 240 as to sine of 115 degrees. So solving for Fu by cross multiplication, 240 sine 25 degrees divided by sine 15 degrees. So again, Fu 240 sine of 25 divided by sine of 115 degrees. So using your calculator there, Fu can now be computed, which is 111.9 newtons. While Fv is equal to 240 sine of 40 degrees divided by sine 115 degrees. 240 sine 40 degrees over sine 115 degrees. So FB is equal to 170.2 newtons. So that's it for problem 2. Problem 3, resolve the 360 Newton force into A, X, and Y components and V, U, and V components. I will not present the X and Y components because we have plenty of examples of that. I just explain it here, but you'll be the ones who solve it as short exercise. So this is the 360 Newton force. These are the information. So with respect to X and Y, although I'm not presenting the solution, we draw lines parallel to the x-axis and parallel to the y-axis. So this and this. So the parallelogram form reduces to a rectangle, and we have a right triangle here. This is 50 degrees. So this is the adjacent side is fx. The opposite side is fy. Both fx and fy are positive. So for fx, this is adjacent to 50 degrees. Fx is 360 hypotenuse cosine of 50 degrees. So you'll be the ones to solve that. Then fy, which is this, for equal to this, and we have an imaginary right triangle. Fy is equal to hypotenuse 360 sine of 50 because it is opposite. So you'll be the one to wants to compute that. Fy is 360 times sine of 50 degrees. I'll now proceed to Fu and Fv. So let's have Fu here along u-axis and Fv along v-axis. Then we draw lines from the tip of the resultant or the force to the parallel to the u and parallel to the v to form that parallelogram. So that's it. That's the parallelogram, but we will only deal with the left or the right half of that parallelogram, and it becomes a triangle. Which is this triangle here. This is supposedly FB, parallel to that side. So by principle, again, one angle or the angle between the U and the 360 Newton force is 20 plus 50. That's 70 degrees. So again, this is 70 degrees because adjacent angles. So this is 100. That's 70 degrees, and the angle here, this total angle here, is equal to this angle here, the angle between the U and the V-axis, because this is the U, and this is the V-axis also, because parallel to that, the V-axis. So what is the measure of the angle between the U and the V-axis? So 20 plus 50, 70. The measure of this angle is 40. 40 degrees is 90 degrees because the angle between the x and the y-axis is 90. Then we have 50 degrees here, so that means that's 40 degrees. Plus 30 degrees, so that's 70 degrees. So 70 degrees plus 40 degrees plus 30 degrees, or it's like 70 degrees plus 70 degrees, so 140 degrees. This is 140 degrees, therefore this is 180 minus 140, so 40 degrees. Since this is 40 degrees plus 30, 70 degrees, it is equal to this, 70 degrees. That's 70 degrees. This is also 70 degrees, so we have an isosceles triangle. Opposite angles are equal, therefore opposite sides are equal. FU is opposite to 70 degrees, FV opposite to 70 degrees, therefore FU equals FV. But we need to solve that. So I mentioned that this is 40 degrees because this is 140, 180 minus 140 is 40 degrees. It's really true because the sum of the interior angles of a triangle is 180, and this is already 140 degrees. So This angle is 180 degrees minus 70 minus 70, so that's 40 degrees. Having known that that's 40 degrees, by sine law, we have Fu as to sine of 70 degrees equals Fv as to sine of 70 degrees equals 360 newtons as to sine of 40 degrees. So Fu equals Fv equals 360 times sine of 70 degrees over sine of 40. So Fu equals 360 times sine of 70 degrees over sine of 40 degrees. So using your calculator, Fu equals Fv can now be computed 526.3 newtons. Then let's have the resultant of coplanar concurrent forces, concurrent force system. So let's just consider three forces. It may be more than two or more forces, and we find the resultant. In this case, I'll just consider three forces. This may be more. This may be more. There may be more than 3, 4, 5, 6, or so many forces acting at a common point. So they are concurrent, and because they lie on the same plane, they are also coplanar. So one technique in parallelogram law, we can combine F1, we can add F1 and F2 vectorially, sum of two vectors by parallelogram law by drawing parallel sides or the free vectors of each force as shown. Then this is the resultant for the sum of forces F1 and F2, but vector sum that do not add the magnitude. It's vector, so you solve the triangle or the parallelogram for the magnitude of that diagonal. So I will remove F1 and F2. This F1 and F2 is replaced by this single force called the resultant. And this resultant is simply the vector sum, take note, vector sum of F1 and F2. The magnitude of this is simply just like before, you consider a triangle, then apply sine law or cosine law, then we can find F1 plus F2, the magnitude only, and the direction is the angle that it forms with the x-axis. So the three forces are now reduced to two forces, F1 and F1 plus F2, vector sum, this single force which represents F1 and F2, and F3. So by parallelogram law again, we draw lines parallel to the tips of each force to form that parallelogram. So from the tip here, parallel to F3, then from the tip here, parallel to F1 plus F2 as shown. So therefore, we remove F3, we remove F1 plus F2. These three forces, therefore, are represented by that single force drawn from the initial point of from the tails of the three forces to the tip of the last force. So that's the resultant, the diagonal of the remaining forces, F1 plus F2 and F3. And this is the parallelogram. So we will call that R, which is the vector sum of F1 plus F2, F2 and F3. So F1 plus F2 plus F3. But we must resolve this force into its x component. This is the horizontal projection of that force, the vertical projection of that force, and the angle that it makes with the x-axis is denoted theta x. So for this situation, the resultant lies in the first quadrant. So both Rx and Ry are positive. So that's 90 degrees there. And that this is a right triangle. Now, the resultant may not always lie on the first quadrant. It may lie in the second quadrant, third quadrant, fourth quadrant. And remember, the signs of the components of R. If it lies in the second quadrant, it means the x component is leftward, the y component is upward, or leftward component means negative, but the y component is positive. It's like that. Now, this same resultant is obtained if we have another technique, instead of parallelogram law, applying the principle or concepts of parallelogram, we apply the force to tail approach. What's the force to tail? We simply connect the second force from the tip of the first force. So this is F1, that is F2, and from the tip of the second force, we connect the tail of the third and last force, which is this one. And remember that this is, this one, which is this. And remember that the resultant is also the vector drawn from the tail of the first force to the tip of the last force. Again, the resultant is the same. This one, the one that closes the supposedly open polygon. So that the polygon is closed, then that represents the resultant from the arrange into tip to tail approach. So this is the first force. We connect the second force. This is the original second force. This is parallel and equal. Then the third force, which is this. Then from the tail of the first to the tip of the last force, that's also the resultant. This is the same, even if we apply parallelogram law. So it's obvious. So therefore, from the figure, we have Rx. So we have F1, F2, F3, this green here. So it ends up with the same tip. So this is these are the components of F1. Negative F1x because it is leftward, but positive F1y. Components of F2, positive F2x, and this is positive F2y. And components of F3, so that is, these are the components. F3x is positive, while F3y is negative because it is downward. So that negative F1x plus this component, so 0. So the x component, the net x component would be beginning with this. Then there's no increase in the x component plus F3x. That's why it is equal to Rx. So R sub x therefore is negative F1x plus F2x plus F3x. That is Rx. Negative F1x because F1x is negative plus F2x plus F3x. In short, R sub x is simply the sum of the forces along x. Then, of course, along x, you treat those components that are positive as positive. Those components that are rightward. Components that are leftward would be treated negative, just like F1x here. Likewise, Ry, this is Ry, which is positive because it is upward, is F1y. There's no change in the resultant, magnitude of the resultant for y, plus F2y. There's no change in resultant, then plus negative F3y, it ends up with there. So that's why Ry is also summation F1y plus F2y, then plus negative F3y. Or simply Ry is summation of forces along y. And treating those components y, positive when they are upward, negative when downward. And therefore, the magnitude of R is equal to, this is the analytical way using the parallelogram law, but you have to solve that by either sine law or cosine law. But here we simply add components into rectangular components which can be easily computed. So R, magnitude of R is square root of Rx squared plus Ry squared. And the tangent of theta x is opposite Ry over Rx. Now, as I said, the angle theta x should be emphasized. And the components If the force lies in the second quadrant, the angle is between 90 and 180 degrees. So it is counterclockwise. Remember the positive sense. And if it lies in the third quadrant, both components are negative. In the fourth quadrant, the x component is positive, the y component is negative. Then theta may be based from the positive x-axis in counterclockwise direction, or you just put the direction of the resultant, then indicate the angle that that resultant makes with the x-axis. So that's the other way. For the examples, I will upload more problems from statics. And for other principles such as uh, principle on transmissibility of a force, it will be also uploaded. Principle for the Varignon's theorem, it will also be uploaded in detail. That's it.